Okay, this next assignment can be a little bit confusing. It can be a nightmare if you kind of don't know the strategy. Okay, I want you to get good at identifying the form this is in. Here you got y by itself, x on the other side with some operators. That's in slope intercept form. Here you have x and y on the same side together of the equation, so that is standard form. We're back to having y by itself with x with the operators, so that is slope intercept form. Don't write this, remember slope intercept, that's m, that's slope, that's y-intercept. Here the x and y variables are on the same side being added together, so that is in standard form. Here's the y by itself, x is here with some operating going on, so that is slope intercept form. X and y on the same side, and that would be in standard form. And y is by itself with x on the other side with some operators. That is in slope intercept form. So hopefully now you get the hang of knowing what form. I'm not even going to bother insulting people's intelligence. That's a greater than sign. Greater. What are possible values for x if x is greater than or equal to 3? Well, it can be equal, so 3, 4, 5, 6, yada, yada, yada. What are x is less than or equal to negative 2? So possible values for x. We got the equals, so you can have negative 2. Now you're less than. Negative 1 is not less than negative 2, okay? Because on a number line, less than's this way. So negative 3, negative 4, negative 5, yada, yada, yada. Okay? Based on a number line, kind of greater than is right of the number, less than's left. Pretty easy. Now, the reason this can be a pain is because now what we did before is the graphs were always continuous. You just put arrows on both ends, but here now what these are called, they're called discrete. Okay? Discrete means there are limits and boundaries for the graph. Okay? And it's known as a domain. Okay? Domain. It says a domain is restricted to x is greater than or equal to 2. But we won't worry about the domain. But first I'm going to graph the full line as if though that wasn't restricted. Okay, so the y by itself, x over here. So that's slope intercept form. So I want to graph this using the slope and y-intercept method. Okay, now slope is m, y-intercept is b. So the m is multiplied by the x. Here it's an integer, so we want to put a 1 under it. And the y-intercept, and then whatever's being added, that's your 3 with a 0. So we want to get that coordinate down first. So x being 0, y being 3. Okay, then my slope, it's rise over run. Vertical, up, down, so it's negative, so that'll be down, and then to the right. So from here I go down 1, 2, 3, 4, 5, right 1. I'm going to do it again. 1, 2, 3, 4, 5, right 1. Now we take a ruler and graph the line as though I don't have to worry, I don't have any other worry. Make it long. This assignment, the lines need to be long. Now, here's how I make my graph discrete. x2, so on the x-axis, go find where positive 2's at, right here, okay? I'm going to mark 2 right there. Now, you need to draw a straight horizontal vertical line, please. Straight horizontal vertical line so that you run into your line, okay? The first line you made. So I go through this 2. Now, moving up, I would never hit my line, I would have to move down, okay? So here, and then when you run into it, circle the point where you run into it at. Make a point if it's not there. If it's there, just circle the point you're at. Now, this graph has now two halves. It has to the right is greater than, okay? To the left is less than. Kind of, you can see right, left. What is the sign? Greater than. So we want to keep the greater than part. We want to eliminate all parts that go this way, okay? Like that. Now, I'm going to come back and do something else, but I want you to get good at this. So yeah, it actually starts here and continues on through that. Okay, y equals 2/3 x minus 5. So again, the y is by itself, x has operators. So slope, intercept, form. And this is discrete over here because I can see that our domain has a restriction. Okay, it's not continuous. So we got slope and y-intercept. So the slope is m, the y-intercept is b. So mx and b, that'd be plus -5 though. Slope's 2/3, already a fraction, and the y-intercept's -5. So, and with 0 in front. So x 0, y 1, 2, 3, 4, 5, down -5. And then it's vertical, so it'd be up 2, right 3. So I go 1, 2, right 1, 2, 3. Do it again. And you have your line. This one's much easier to deal with. That line, that first line was pretty steep. Okay. All right, now the graph is discrete. We go to -1 on the x-axis. Now, if we're going up, I'll never intersect the line. I have to go down. Now, there's no point there, so I make one myself and circle it, okay? Now, to the right's greater, to the left is less, okay? Well, it says less than, though. So I need to keep the part that's less than. I need to eliminate the part that's greater than. You can also erase it if you're using a pencil, okay? So it's a discrete graph. It starts here, it goes this way. Okay, now, x and y here are on the same side, so that is in standard form. So I'm going to graph this differently. I'm going to make my table in standard form. The best way is to find 2 points with zeros in for each variable at each point. So I have 5x minus 2y equals, plus negative would be better. And then 5x plus -2y equals 20. So x being 0 means 5x goes away. And then you have -2 times y equals 20. So I need to divide by -2. And that gives me -10 for the y, okay? So x is 0. I probably go by 2's. 2, 4, 6, 8, 10. That's the y-intercept. So 0, -10. Okay, now the x-intercept, the y is 0. And we can eliminate that because the product of anything in 0 is 0, which leaves me with 5 times x equals 20. So 20 divided by 5 is 4. Okay, so then that's your x. X is 4. 1, 2, 3, 4. All right, take your ruler, graph the line. I don't need you writing the equation on the line today, okay? That's not, if it's discrete, that gets in the way. Okay, so I go to +3, 1, 2, 3. There's 3. Well, from that, I'd have to move down. I ran into it, make a point. Okay, circle the point. To the right of the point, you know your right from your left. Right, left. The right is greater than, the left is less than. Well, the sign's less than, so I keep the less than part while cutting off the part that's greater than 3, because I only want a line that contains x coordinates less than or equal to 3. Okay, all these have x coordinates greater than 3. Okay, next one, x and y on the same side. That's standard form. So once again, do the same thing. So write the equation out twice. So x being 0 means I can eliminate the x. 4 times 0 is 0. 18 divided by negative 6 is negative 3. Okay, so I stay in the middle, go down 1, 2, 3. And then y being 0. Okay, cross divide by 4, and that's 4.5. Okay, so I'm going to go right 1, 2, 3, 4, and then halfway, and then that y is 0, so stay in the middle of the y-axis. And take your ruler, and away we go. Now, this time it's -1, so I go to -1 on the x, okay? And I have to go down, and then if there's not a point there, make one and circle it, because that's your cutoff point. To the right's greater than, to the left is less than. And what sign is that? Looks like it's greater than to me, so we keep the greater than part, and we don't want any of these. Okay, it's discrete. Okay, and then I got these are going to be easy to do the discrete part. These are -1 less than or equal to x less than or equal to 1. And what this means, let's just not overthink the signs. And what that means is I want all points for x between these two. So here's the y by itself, x over here with an operator, and that would be then slope-intercept form. So slope represented by the m and y-intercept represented by the b. Okay, so the slope's going to be the multiplier, -5. That's an integer, so over 1. And then the y-intercept had a +0, and it's 0. So the y-intercept here is our origin. Then from there, negative, I go down and to the right. So 1, 2, 3, 4, 5, right 1. I can't do it again. Okay, it's a very steep line. It's kind of annoying doing these discrete restrictions when the... Okay, so -1, you got to mark 2 points. -1 on x is here, so I'd have to move up to intersect the line. Okay, circle it. +1 is right here. You'd have to move down, but there's already a point there, so circle it. Now, what that means is you want to eliminate all points outside that. Okay, you want to keep the middle. You don't want to overthink the signs when it's like this. All that means is between. So I only want x coordinates between -1 and 1, and that gets the job done. All right, my next problem. Again, the y is by itself, x is over here with operators. So slope, intercept, form. So slope, y-intercept. So that's m and that's b. Okay, so m and b. So m is the multiplier of the x. So 5 being an integer over 1. And then plus b, so it'd be -2 was 0. Okay, so stay in the middle, go down 2. All right, and from that point, rise over run. Rise of 5, run of 1. So 1, 2, 3, 4, 5, right 1. You can do it again. Make a point. Oh, darn lucky the batteries didn't fall out there. That would have sucked. Okay, so -1 here. You have to go down to hit the line. And +2 right here. There's already a point there, so you have it. And I want only points between the two. I don't want any points outside. Okay? That's how I choose to do it. There are other ways to explain this, but okay, my next problem. This time X and Y are together, so that makes this in standard form. And again, XY table is the best route to take with 0 and 0. So 2x minus 6y equals -18, and I write it again. Plus negative is a better choice. Okay, so x is 0. Eliminate that. And that's a -6. Unfortunately, I didn't draw that, so I divide by -6, and that's +3. So if x is 0, y ends up as +3. So I stay x is 0, so the middle, and then up 1, 2, 3. Okay, y is 0. So -6 times 0 is 0. And 2 divided by 2, and that's -9. Okay, so I go to -9 on the x. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's your x-intercept. Okay. All right, so now it's a matter of graphing those points. And these restrictions are easy. -4, 1, 2, 3, 4, 1, 2, 3, 4. So -4, I go up. +4, go up. And we want only in between, so we need to eliminate those.